Alright, hello class. This is take number 7. Hopefully I can finally get this recording down. You should already have a printout that looks similar or the same as this, except it's in white. You should have 2 pages. Two pages front and back. First page is the notes, second page is the homework. You you have enough time to do it during class. It's not really homework. Turn in at least the front page of the homework side, please. Alright, so let's start the lesson. If you haven't noticed, today's lesson we are going to cover area of a regular polygon. Now the first question that begs to be answered is, what is a regular polygon? A regular polygon is just any polygon with congruent sides and angles. I hope you guys know what congruent means. If you don't, congruent just means equal or same. Congruent sides and angles. Now, before we talk about how to find the area though, I need to show you parts of a regular polygon. First, the distance from the center of a polygon to any side is called the apothem. You guys should have learned this already. The apothem is from the center to the edge. I would call that A. Now, the radius of a regular polygon is a distance from the center to a vertex. We'll call this the radius. Now, the formula for area of a regular polygon, this should be, let me check if it's in the, what's it called? Formula sheet that you will get for the exam. Give me 1 second. I'll tell you guys later. Anyway, you should memorize it either way. The formula is area is equal to 1/2 times the apothem times the perimeter. And the perimeter, I hope you guys already know how to do this. Perimeter of a regular polygon is P is equal to side length times the number of sides. So side length times the number of sides. For instance, of this regular hexagon, let's say the side length was 2. Okay? How many sides do we have? 1, 2, 3, 4, 5, 6. So 2 times 6 would give you 12. Pretty simple, I think, on how to find perimeter. Sorry, I shouldn't do that, but anyway. It happened. Oh no. Guys, I don't like technology, but I'm trying. I'm trying here. There it is. Okay. Let's go on to practice problems now. Practice problems. If I can erase this. Bear with me for a little bit. Bear with me. Aha. Now we can zoom in. Perfect. Yeah, this Apple Pencil is kind of weird. But anyway, I got it. We got it. Alright, so find the area of each regular polygon. Let's start. If it's a regular polygon, step number 1, always write down the equation of the area. Area is equal to 1/2 apothem times the perimeter. Let's label the parts of this regular triangle. Well, first of all, 7 is the apothem because it is distance from the center to the edge. Alright, now, how do we find the perimeter? Well, the perimeter, like I just talked about previously, is the side length times the number of sides, which is 3. So it's 24.2 times 3. That will give you the perimeter. So let's put that into the equation. Step number 2, substitute. So area is equal to 1/2 apothem, which is 7, times the perimeter, which is 24.2 times 3. Therefore, the area here is 254. Oh, that's not right. 254.1. Well, we need to have units, so it's feet squared. Should be pretty simple. Let's look at the next example problem. Here we have a regular polygon again. Write down the equation of the area, which is up here. Area is equal to 1/2 apothem times the perimeter. Well, the apothem here is 16 because it is the distance from the center to the edge. And now we found the apothem, we need to find the perimeter. The perimeter is always the side length times the number of sides that we have. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8. So it's 13.3 times 8 will give you the perimeter. Great, we just substitute that into the equation, and this into the equation, we're done. So area is equal to 1/2 apothem, which is 16, times the perimeter, which is 13.3 times 8. Which should give you, if you put it in the calculator, oh, you guys might not have a calculator today, so use the ones on your computer. 851.2 centimeters squared. Now, however, pause it to copy it down, etc., etc. Play it back when you're ready. Now, I'm going to go to the next part. Unfortunately, problems are not going to be so nice to you where they give you both the area, both the apothem and the side length of a polygon. Sometimes you have to find the apothem or the side length given one. So you have to find the other. So let's look at this example number 3. Example number 3, we're given only the apothem, which is 5 meters. Are we given the side length? No. So we need to find it. And the steps are provided up top. Step number 1, create a right triangle by drawing the apothem and radius. Question number 1. Okay, let's do this. There you go. First, draw the apothem here, which they have already drawn for us. So we know that the apothem here is 5 meters. Perfect. Now draw the radius. If you remember, the radius is a line segment from the center of the polygon to the vertex. That we will call the radius. Now, step number 2. Find the measure of the interior angle where the radius intersects the vertex. First, we need to use the interior angle sum formula, which is S is equal to n minus 2 times 180, where n minus 2 represents number of sides. And number of sides, plug that in. For us, right now we have 6 sides, so 6 minus 2 times 180, which will give us, what is that? 4 times 180, 360, 720. So that is the interior angle sum. So that is all the angles added together. But we are looking for the measure of half of one angle. How do we do that? Well, divide the sum of all the angles divided by the number of angles. Okay, so 720 divided by n will give you 720 divided by the number of sides, which is 6, will give you 120. However, 120 is just this theta. We're looking for this angle, which will give you, which is half of it, so it's theta divided by 120. Sorry, that's wrong. Theta divided by 2, which will give you 60 degrees. So each angle measure, this one, is 60 degrees. Okay, now we use trigonometry or special right triangles to find the apothem and or side lengths. I'm going to erase this part. I hope you guys can go back and rewind whatever to watch this part, but I need the space. So now we have a right triangle. Draw it out. Right triangle where this is 60, this is 5, and we need to find this right here, the base, because that will give you half of a side of a polygon. Well, in this case, we know the ratio of a 30, 60, 90 triangle is square root 3 x 2x. How do you go from this side to this side? You divide 5 by square root of 3. So the side length is x is equal to square root of 3. Oh, sorry, that's wrong. So it's 5 divided by square root of 3, and that will give you x, the short side of a 30, 60, 90 triangle. If you don't remember, I'm going to draw it out bigger. It's x square root 3, 2x. So you have a 30, 60, 90 triangle, which we have here. If we know that the side is 5, how do we go from here to here? We divide by square root of 3. We want to get rid of the square root 3 to get x, so it's 5 divided by square root 3. Just leave it as is. Well, technically it's more like 5 square root 3 over 3. Now we have the half of a side length. So the full side length, S is equal to 5 square root 3 divided by 3 times 2, which would give you 10 square root 3 divided by 3. Oh, but we're not done. Now we need to find the perimeter. Perimeter is equal to the number of sides times the side length. In this case, it is, how many sides do we have? 6 sides. 6 times 10 square root 3 over 3, which would give you 20 square root of 3. Now we can find the area. If you recall back, area is equal to 1/2 apothem times the perimeter, which is 1/2. Apothem here is 5, since it's given, and the perimeter is 20 square root 3, which should give you 50 square root of 3, and that is the answer. I know it's a lot. I'm going to go through another one. Don't worry. Because it's not always handy dandy like this. Okay. I'm going to erase this. So pause it and then rewrite the notes. They didn't look very nice. Oh well. I'm already too deep into this problem. I'm going to erase this part because I need the whole entire space. Perfect. Let's do number 5 and I'll do number 6, and then you are on your own after that. Number 5. First of all, write down the equation of area for a regular polygon. Area is equal to 1/2 apothem times the perimeter. Are we given the apothem? Yes. Apothem is equal to 10 inches. Can we find the perimeter at this moment? No. Because in order to solve for perimeter, we need the side length times the number of sides. We know that the number of sides of a pentagon is 5, but we don't have the side length s. That's what we need to solve for. Okay, so if you look at the instructions above, you'll notice that first, draw the apothem and the radius. Fortunately, it is given to us. The apothem is 10, and the radius, we don't know. But that's what it is. We're trying to solve for 1/2 of s. Let's just call that x for now. We're trying to solve for x. Let's draw this right triangle out bigger so we can know what we were looking at. Boom, boom, boom. 10xr. We can find this angle right here, theta. If we find this angle, we can use trigonometric function to solve for x. I'll show you how. First of all, let's solve for theta. Okay, in order to solve for theta, first we need to find the sum of all angles in this pentagon. Sum of angles is equal to n minus 2, where n is the number of sides, times 180. Where n is, let's say, 5, so it's 3 times 180, 360. I'm doing the math in my head. 540, is that right? Yeah, that is equal to 540 degrees. Once we find the sum of all the angles, now we need to find the measure of each angle. Well, the measure of each angle is just 540 divided by n, where n is the number of sides, so it's 540 divided by n, which will give, 540 divided by, not that, 540 divided by 5, which will give you 108 degrees. So the measure of each angle is 108 degrees. This is 108 degrees. Unfortunately, that's not what we're looking for yet. We're looking for theta. Fortunately, theta is just half of 108. Because if you draw a radius to an angle, it just cuts this angle in half. So 108 divided by 2 is equal to 54 degrees. Aha. Finally, we found what we're looking for. So theta over here is equal to 54 degrees. Now, Mr. Y, how the freak do we use trig functions to solve for x? I will show you. Well, if you look at theta, what relationship is x and 10 in relation to theta? Well, it is the opposite side of theta and it is the adjacent side of theta. So let's look at SOHCAHTOA. Which of the trigonometric functions has an opposite and adjacent? Oh wait, tangent. So let's use tangent. Now, the trigonometric functions represent a ratio between the two sides that we are given. In this case, the tangent of 54 degrees is equal to the ratio of the sides opposite over adjacent, which in this case is 10 over x. Now we solve for x. You should get that x is equal to 10 over tangent of 54 degrees. If you put that in the calculator, which you have to, make sure it's in degrees. I repeat, make sure it's in degrees. You should get 7.27. Oh, okay. Here's the good part. Now that we found that the side length, or half the side length of the triangle x is equal to 7.27, then we know the entire side length is x times 2, which is equal to I don't know, 14 point something. Let's just call it 14.5. Yeah, that's a good sign. That's a good number. Now we know the side length. Now we can find the area. Here it is. Area is equal to 1/2 apothem times the perimeter. Area is equal to 1/2 apothem, which we know is 10, times the perimeter, which is 14.5 times the number of sides, which in this case is 5. So it's 1/2 times 10 times 14.5 times 5. And now that the area is around 363.5 inches squared, and we should be done. Yeah, we're done. That was a lot, wasn't it? Alright, I'm going to do one more practice problem. If you want to stop there, that's fine. If you want to follow along, go ahead. Let's do... I feel like I should do number 6. But instead, I'm going to do... Go to the next page. Man, why can't I move this? Why isn't anything moving? There it is. Please go to question number 7. Last time we were given the apothem, now we are given a side length. Okay, so let's write down the equation of area again. What do we need? Area of a regular polygon is equal to 1/2 apothem times the perimeter. We don't know what the apothem is, so we need to solve for it. However, we do know the perimeter. The perimeter is equal to the number of sides times the side length, in this case, which is 5 times 8, which is equal to 40. Great. Now we need to solve for apothem. Step number 1. Draw a radius from the center of the polygon to the edge. Now we have a right triangle, and this side is 4. We're solving for apothem A. In order to solve for A, however, we need to find this angle theta. I'm going to draw it out bigger so you guys can see. Not that much bigger, but it's bigger anyways. Apothem, right angle, this is 4. We need to solve for theta. We need to solve for theta first before we can solve for A. Well, theta is 1/2 the area, so 1/2 the measure of this interior angle. Okay, I'm going to do the math real quick. I'm just going to say, we're going to call this y. Angle y is equal to n minus 2 times 180 divided by the number of sides, and n minus 2 times 180 will give you the sum of all the angles. N is the number of angles that we have. In this case, it's 5. So it's 5 minus 2 times 180 divided by 5 will give you 108 degrees. So we know that y is equal to 108 degrees. Therefore, theta is 108 divided by 2, or 54 degrees. Perfect. Now that we know theta is 54 degrees, now we can use trigonometric functions to solve for the apothem. First, in regards to this angle theta, where is the apothem and the 4? Well, the apothem is the opposite side of the theta, and 4 is the adjacent side. If you look at SOHCAHTOA, which of the trig functions uses opposites and adjacent? Ding, ding, ding. It's TOA, tangent. So now we can set up a relationship of tangent of 54 degrees. Remember, trigonometric functions, regular trigonometric functions, describe the ratio of the sides given, which is opposite and adjacent. So tangent of 54 is equal to opposite over adjacent, which is equal to a over 4. If you solve for a, you find that a is equal to tangent of 54 degrees times 4. Make sure your calculator is in degrees, which will tell you a is equal to around 5.51. Now we just need to find the area. Area is equal to 1/2 apothem times the perimeter. We found the apothem is around 5.51. We found the perimeter was 40. And now we know that the area is around 110.2 feet squared. Oops, inches squared. And now we are done. Whew, that was a lot. Thank you guys for listening. I appreciate it. If you guys can give me feedback on the video, that'd be great. Alright, I'll see you guys tomorrow with the next video.